The overall goal of this procedure is to create a well-vascularized tissue flap to be exploited for reconstruction of full-thickness abdominal wall defects. This is accomplished by first preparing a biodegradable polyl-lactic acid polylactic coglycolic acid scaffold. Next, endothelial cells, muscle cells, and fibroblasts are seeded, and the graft is cultured in vitro to allow the cells to self-assemble. Then, the engineered tissue is implanted around the femoral artery and veins of the mouse, where it undergoes anastomosis with host vessels and becomes highly vascularized. Finally, the tissue is transferred as a pedicled flap to a full-thickness abdominal wall defect. Ultimately, graft vascularization is proven by ultrasound, Fitzy-dextrin injection, and immunostaining for CD31, and flap stiffness is examined using a biodynamic test instrument.
The main advantages of this technique over existing methods are lower donor side morbidity and high variability of the engineered flap that can be used for the reconstruction of full thickness soft tissue defects.
This method can help treat patients with full thickness abdominal wall defect.
Demonstrating the procedure will be done by Dr. Egozi, a plastic surgeon working in collaboration with my laboratory, and Alina Freiman will assist her.
After preparing scaffolds and embedding cells according to the text protocol, autoclave the following surgical tools.